Let's continue our discussion on networking. From a security standpoint, in Azure there is a concept of network security group. Think of it like a virtual firewall for controlling traffic in and out of your virtual machines and subnets. It basically contains a set of security rules that is going to either allow or deny inbound and outbound traffic. NSGs can be associated to multiple network interfaces and subnets, but each network interface or subnet can only be associated to one NSG. There is also a concept of the priority order. So the lower the number of the rule, the higher is the priority. And NSGs also come with default rules. So there are 3 default inbound and 3 default outbound rules. And these default rules cannot be deleted. In case you want, you can override these rules by specifying rules with a lower number. And the traffic can also be controlled by load balancers using inbound NAT rules. In OCI, there are 2 virtual firewall features to control the traffic. The first one is security list that is associated with a subnet, and the second is network security group that is associated with a VNIC. Remember, in Azure, there is one construct NSG, and in OCI, there are 2 different constructs. So you can use security list alone or the network security group alone, or you can also use both together. If you choose to use both, the set of rules that applies to a given VNIC is the union of rules in security list and network security group. Each VCN also comes with a default security list, and you can delete the default rules in case you require to. When you create a subnet, you have the option to associate up to 5 security lists. If you don't specify anything, then default security list is going to be associated, and all the VNICs in that subnet will be subject to that same set of rules. And from an NSG standpoint, a VNIC can be added to a maximum of 5 network security groups. As we discussed, firewall rules are associated with a subnet and applied to all instances inside the subnet. Here you see there are 2 security lists. The first one is attached to a public subnet, and the second one is attached to a private subnet. So in the first security list, you can see that there are 2 rules that are defined. The first rule basically allows port 80 from internet. The second rule is an egress rule that allows traffic to the private subnet over port 1521. Now NSG is a similar construct as security list. It applies only to a set of VNICs in a given VCN. The difference is NSGs can be the source or destination. Now if you contrast the security list rules, you can see that in the security list rules, we generally specify a CIDR as the source or destination. But as you can see here in NSGs, we are using NSG as the source or the destination. Now let's talk about peering. Azure supports virtual network peering within the same Azure region and global VNet peering that is configured across Azure regions. Now after peering is established, the routes are automatically added as a part of system routes. So you don't need to manually add anything. You can also go ahead and configure gateway transit. The one thing to keep in mind is that the ingress and the egress traffic is charged at both the ends of a peered network. In OCI, there are different options for VCN peering. You can configure local VCN peering within the region using local peering gateways. You can also peer VCNs in the same region using dynamic routing gateway, and you can peer VCNs in different regions using dynamic routing gateways. Once the peering connection is established, you basically need to configure route tables. For local peering, there are no charges, and for remote peering, the charges are based on outbound data transfer. So in this architecture on the left, you can see that there is a local peering within the region using local peering gateway. So what are the steps for it? You basically create a local peering gateway on each VCN. You create LPG1 for VCN1 and you create LPG2 or local peering gateway for VCN2. And then you basically create a connection between these local peering gateways. Now once the connection is established, you also need to configure routing. Remember, we discussed that in OCI, you need to explicitly add the routes after the peering is configured. On the right hand side, you can see the remote peering. Using this remote peering, we can peer VCNs in different regions, and you can see that there is a dynamic routing gateway that is attached to each VCN, and then there is a remote peering connection between these dynamic routing gateways. Now, after the peering connection is established, again, in the case of remote peering, you have to add the routes in the route tables and also configure the security rules. Now this slide talks about the dynamic routing gateway enhancements. Now you can use this dynamic routing gateway to manage communications between the VCNs. Now, what is the benefit of this? The benefit is it provides enhanced scale and a more simplified management experience. You no longer need to maintain a point-to-point connectivity using a local peering gateway, and instead you can use dynamic routing gateways to communicate between the VCNs. This feature basically allows you to scale up to 300 VCNs on a single DRG, and if you think that this option isn't enough, you can also connect an extra dynamic routing gateway through a remote peering connection. Now let's talk about load balancers. In Azure, there are two types of load balancers: Azure Load Balancer that operates at layer 4 and Azure Application Gateway that operates at layer 7. Azure Load Balancer operates at the transport layer and it is available in both public and private flavors. Azure Application Gateway operates at the application layer. It makes routing decisions based on additional attributes of an HTTP request. Azure Application Gateway provides features like SSL offloading, path-based and multi-site routing. In OCI, there are two types of load balancers. The first is Network Load Balancer and the second is Load Balancer. Network Load Balancer is a layer 4 load balancing solution that provides the benefits of low latency and source IP and port preservation. There is no need to specify shapes as they are scalable. Load Balancer, on the other hand, is a layer 7 load balancer and includes advanced proxy features such as layer 7 routing and SSL termination. In case of load balancer, you can pick the type and size of bandwidth shape for your load balancer. And there are basically two types of shapes. The first is flexible shape, where you choose the minimum and maximum bandwidth, and you can specify from 10 Mbps to 8 Gbps. And then there is a dynamic shape where you get an option of predefined shapes. Basically, there are 4: micro, small, medium, and large. And as we discussed in the last slide, Network Load Balancer is a layer 4 load balancer. It understands TCP and UDP. It can be public or private. It is highly scalable and there is no need to specify any shape information. Basically, it is faster than HTTP and HTTPS load balancer. It provides lower latency. And one of the use cases that you can think of for Network Load Balancer is to use it for performance sensitive applications. Then you have the layer 7 load balancer. It basically understands HTTP. It can also be public or private. It's highly available, it's highly scalable, and it's available in flexible or dynamic shapes. Alright, to wrap up, in this lesson we discussed OCI networking by highlighting the similarities and differences with Microsoft Azure networking offerings. I hope you found this lesson useful. Thanks for watching. Hello and welcome to this demonstration. In this demo, I'll show you how you can create a virtual cloud network and a public and a private subnet. So let's get started. Click on the hamburger icon. Click on networking. Click on virtual cloud networks. Now you have two options to create a VCN. You can create the VCN manually by using this create VCN option, or you can also use the start VCN wizard to quickly get started with some common architectures. We are going to use the process of manual creation. So let me go ahead and click on create VCN. Let me give it a name and define the CIDR block. So I have defined the name as test VCN. I am creating it in compartment sumwidth. Let me provide a private IP address range. You can also optionally enable IPv6 CIDR block, but I am keeping all the options as default. I also want to use the DNS hostname in the VCN. So I'll go ahead and click on Create VCN. You see that the VCN is now created and is now available. Now let's inspect the resources that gets created by default when you create a virtual cloud network. So as you can see, the VCN is available, but we don't have any subnets. We have a CIDR block that we added. There's also a default route table that gets created. If I click on this default route table, you don't see any rules, right? So a default route table is created without any rules. Then we don't see any internet gateway or any of the other gateways like local peering gateway, NAT gateway, service gateway. So there is nothing here that has been created. But one thing that I want you to focus on is this security list. So when you create your VCN, by default, there is a security list that gets created. The name is default security list. And if you click on this default security list, you can see there are 3 ingress rules and there is 1 egress rules, right? So this is by default. Now let me go ahead and create 2 subnets. I will create one public subnet and the other one as private subnet. So click on subnets, click on create a subnet, specify the name and select the compartment. So first I'm going to create a public subnet, and you see the subnet type. There are 2 options. One is regional, that is recommended, and then you have availability domain specific, right? Where the subnet is only going to sit inside a particular availability domain. Here the subnet can span multiple availability domains, and this is the recommended configuration when it comes to high availability. So after specifying the name and selecting the compartment, specifying the subnet type, let me specify the CIDR block. So we are creating this public subnet, right? So the next option, subnet access, we have to select public. This basically allows public IP address for instances that you are going to deploy in this subnet. I'll keep other options as the default and click on create subnet. In the meantime, this subnet gets created. Let's go ahead and create another subnet. And this time I am going to create a private subnet. So I'll click on create subnet. This time I am going to create a private subnet. I will specify the subnet type as regional, and let me define a CIDR block. And you also see that we can also associate a route table while creating a subnet, right? As of now, we just have the default route table, and by default it gets attached. But in case you create a custom route table, you can also associate that route table while creating a subnet. This time I will go ahead and select the subnet access type as private subnet and not public, because we are creating a private subnet. So I'll click on private subnet and then click on create subnet. So as you can see, we have created a public subnet and a private subnet, and you see that public subnet is already available. In some time, the private subnet is also going to be available, right? And you see it is available. So in this demonstration, we created a virtual cloud network, and we also saw how we can create a public subnet and a private subnet. I hope you found this demo useful. Thanks for watching. Hello and welcome to this demonstration. In the previous demo, we created a virtual cloud network and we added two subnets. First was public subnet and then we added private subnet. In this demonstration, I will show you how you can create an internet gateway and a route table. So let's get started. To create an internet gateway, under resources, click on internet gateways. Click on create internet gateway. Specify a name. Select a compartment and click on create internet gateway. So you see that this internet gateway for this test VCN is now created. Now let me go ahead and create a route table. Click on route tables. You see that by default there is a route table that gets created when you create a VCN, but I want to create a custom route table. So click on create route table. Specify a name. Select a compartment and click on create. So you see that the custom route table is now available. So if I click on this custom route table, I can see the different route rules. As of now, there are none. So let me go ahead and add a route rule. Click on add route rules. Click on the target. The target in this case is going to be internet gateway, and the destination CIDR I will provide. So this is the destination CIDR block. And what is the target internet gateway? This is already the one that I created. And description is optional. So I'll click on add route rules. So any traffic that is intended to internet will be sent to the internet gateway. Click on add route rules. And you see that the route rule is now added. Now the final thing that I want to show you is how you can go ahead and associate the route table that we created to the public subnet. So I will go ahead and go to this public subnet. I'll click on edit. And here you can see the route table in some width, right? So this is the place where you can associate the route table. As of now, it is associated with the default route table. But since this is a public subnet and I want the traffic to be sent out to the internet through the internet gateway, so I will go ahead and select the custom route table and click on save changes. Okay, so now it's done. You see that this custom route table is associated with this public subnet. So in this demonstration, we created an internet gateway. We created a public route table with the name of custom route table, and then we added an entry for internet gateway in the route table, and finally we associated the new route table to the public subnet. I hope you found this demo useful. Thanks for watching. Hello and welcome to this demonstration. In this demo, I am going to show you how you can configure a local peering connection. So as you can see here, there is a test VCN that I have already created. So let me go ahead and create another VCN in the same region with the name of demo VCN. So I've specified the name for this virtual cloud network. I'm creating it in some width compartment, and I have specified 192.168.0.0/16 as the IPv4 CIDR block. The rest options I'll keep it as default, and I'll click on create VCN. So this VCN is now available, and if I go to the virtual cloud networks, you see that there are two virtual cloud networks that are available. Now to create a peering connection between the VCNs that are part of the same region, you have two choices. So let me first talk about the first choice, using a local peering gateway. So I am going to add a local peering gateway in both the VCNs. So let me first do it for the demo VCN. So I am inside the demo VCN, and as you can see here, there is an option of local peering gateway. So let me add one. Create local peering gateway. So I specified the name LPG demo VCN and creating it in the same compartment. Create local peering gateway. Right. So now I have the local peering gateway created in the demo VCN. Let me do that for the other VCN as well. So let me go to the test VCN and create a local peering gateway. I'll click on create local peering gateway. So now you see that I am done with the creation of local peering gateways for both my virtual cloud networks. And the peering status that you see here is not connected to a peer, right? So how do you connect to a peer? Click here and click on establish peering connection. Now you need to specify the local peering gateway, right? So the virtual cloud network compartment is somewhere, that is fine. Let me select demo VCN as the target VCN. This compartment is also fine. And then I will select the local peering gateway that is associated with this demo VCN. So let me select this and click on establish peering connection. Now you can see the peering status as pending, establishing a connection to the peer, and in some time you will see the status as established. You see, now the peering status is peered, connected to a peer. Now one thing that you need to understand is, after you have configured this peering connection, you need to add respective route rules in the route table, as well as configure necessary security rules in order for the communication to happen privately. Now I mentioned that there are two ways in which you can configure a peering connection. The first is using local peering gateways, and we have seen that in action. The second option is using a dynamic routing gateway. So how do we create a dynamic routing gateway and how do we attach it to a particular VCN? So let's have a look at that. Click on the hamburger icon. Click on networking. Under customer connectivity, click on dynamic routing gateway. Click on create dynamic routing gateway. Provide a name. In my case, I have provided demo DRG and I am creating it in this Samvit compartment. Now click on create dynamic routing gateway. You can see that the dynamic routing gateway has been created successfully. So now let me go to my virtual networks. You see I have two virtual cloud networks, right? Demo VCN and test VCN. Now let me attach the dynamic routing gateway that I created to each of these VCNs. First, I will do that for demo VCN. So I'll go to demo VCN and then I will click on dynamic routing gateway attachments, create DRG attachment. I will give it a name. And I will select the DRG, that is demo DRG. Click on create DRG attachment. In the meantime, this is getting attached. Let me go ahead to the second virtual cloud network that I have, that is the test VCN, and again perform the same steps. Click on dynamic routing gateway attachments, create DRG attachment, select the DRG and click on create DRG attachment. So if I go to my virtual cloud networks, You see that this demo DRG is now attached to my demo VCN. And if I go to the test VCN, click on Dynamic Routing Gateway Attachments, you can see that the Dynamic Routing Gateway is also attached to this particular virtual cloud network. Now this is the second option. So you create a Dynamic Routing Gateway, you attach it to the virtual cloud networks, and then the virtual cloud networks can communicate privately. It is the same as peering, right? So in this demonstration, I have shown you both the ways in which you can peer virtual cloud networks that are running in the same region. I hope you found this demo useful. Thanks for watching. Hello and welcome. In this lesson, we will show you what you need to know to translate your Azure knowledge and apply it to Oracle Cloud Infrastructure in the compute space. Let's first do a quick side-by-side comparison of the compute offerings of both these cloud service providers. Both Azure and Oracle Cloud Infrastructure have the concept of multi-tenant virtual machines. Azure calls it virtual machine and OCI calls it instance. Both the cloud service provider also feature a single tenant virtual machine and both call it dedicated host. Both the cloud service provider also have a bare metal offering. In Azure, it is known as bare metal infrastructure. In OCI, it is implemented using bare metal instances. In Azure, the horizontal scaling is implemented using virtual machine scale sets, and in OCI, it is achieved by using instance configuration, instance pool, and auto scaling configuration. Now let's have a quick look at the OCI offering. You can see the two models in the slide. Bare metal instances are instances where customers get the full server. This is also referred to as the single tenant model. The advantage here is that there is no performance overhead, there are no shared agents, and there is no noisy neighbor. On the other spectrum are these virtual machines where the underlying host is virtualized to provide smaller VMs. That is also referred to as the multi-tenant model. The advantage here is flexibility in regard to choice of instance shape. Now the third one is known as dedicated VM host. The dedicated VM host allows you to run VMs with a higher level of isolation using a single tenant model. The creation process is quite similar on both the cloud service providers. You need to provide details like the name, availability options, image, virtual hardware configuration, networking, storage, and advanced options. Instances on OCI are required to have a boot volume, just like Azure Virtual Machine Operating System Disk. However, you can specify a custom boot volume size in Oracle Cloud Infrastructure, and the size can range from 50 GB to 32 TB, unlike Azure, where the operating system disk has a maximum capacity of 4095 GB. Another difference is, in OCI you attach a block volume after the instance is launched and not during the creation process. Now let's look at the purchasing options or capacity types. A key difference for the compute service is that Azure bills per minute while OCI bills per second. Both Azure and OCI offer on-demand instances where resources are allocated instantaneously if the capacity is available. Spot instances on Azure are similar to preemptible capacity in OCI. These categories basically use ideal capacity to create the instances and are meant for workloads that can withstand interruptions. In Azure, you choose a maximum price, and Azure is going to evict your virtual machine when the cost of the instance is greater than the maximum price or when Azure needs the capacity for pay-as-you-go workloads. On OCI, it is a fixed discount price. Upon reclaiming a virtual machine, Azure allows you to stop or deallocate or delete the VM. On OCI, the instance is destroyed and you have the option to preserve the boot volume for future reuse. In Azure, reserved instances provide a significant discount over pay-as-you-go virtual machine pricing by allowing you to pre-purchase the base costs for your virtual machine usage for a period of either 1 year or 3 years. In OCI, capacity reservations enable you to reserve instances in advance so that the capacity is available for your workloads when you need it. There is no size or no time commitments, and you can create a reservation with as little or as much capacity as you need and delete the reservation at any time to stop paying for it. Both the service providers also feature a dedicated host option. This feature lets you meet compliance and regulatory requirements for isolation. In the next lesson, we are going to continue the discussion on compute. I hope you found this lesson useful. Thanks for watching. Hello and welcome. Let's continue the discussion on compute. Let's talk about the virtual hardware configuration. Azure calls it size and OCI calls it shape. In Azure, there are different virtual machine families like general purpose, compute optimized, memory optimized, storage optimized. There is also a high performance compute and GPU option, and there are different VM sizes. In Azure, there is a predefined sizing and no concept of flexible sizing. In OCI, a shape is a template that is going to determine the number of OCPUs, the amount of memory, and other resources that are basically allocated to an instance. For virtual machine and bare metal, standard, dense IO, GPU, and optimized shapes are available. In addition to this, the bare metal instances also have high performance compute shapes. In addition to fixed shape, OCI virtual machines also have the concept of flexible shape, and this is a major differentiator. A flexible shape is a shape that lets you customize the number of OCPUs and the amount of memory when launching or resizing your virtual machine. Optimized shapes also support cluster networking. Now, what is this cluster networking? Think of it like a pool of high-performance compute, GPU or optimized instances that are connected with a high bandwidth and ultra-low latency network. Now, cluster networks are designed for highly demanding parallel computing workloads, for example, aerospace modeling. In OCI, compute shapes are available with AMD, Intel, and ARM-based processors. So I just wanted to call this out because ARM-based processors are not available in Azure. OCI also provides a generous free tier. As you can see in the slide, it provides 4 ARM-based Ampere A1 cores and 24 GB of memory usable as 1 VM or up to 4 virtual machines as a part of its always free cloud services. When it comes to images, both Azure and OCI support Windows Server and major Linux distributions. For OCI, there are several image sources. As you can see in the slide, the image can be platform image. Basically, it is a pre-built operating system. Then it can be Oracle image, can be partner images that are published in Marketplace, or it can be a custom or a community image. Lastly, let's have a look at the horizontal scaling mechanisms in Azure and OCI. Azure implements horizontal scaling with the help of a service that is known as Virtual Machine Scale Set. While defining a scale set, you specify the image, the initial instance count, and the scaling policy. OCI implements auto-scaling using 3 components. The first component is instance pool. You can think of it like managing multiple instances as a group. The second component is instance configuration that basically defines which template is going to be used when creating an instance. And the third component is auto-scaling configuration, using which you can scale in or scale out the number of instances in an instance pool. Now, just to remember this, you can think of instance pool as where, instance configuration as what, and auto-scaling configuration as when. OCI supports both metric-based policies. That means you can have an auto-scaling policy that is triggered when a performance metric exceeds a threshold, as well as schedule-based policies. In schedule-based policies, basically the auto-scaling events take place at specific times that you schedule. And as you can see, there are some limits in both Azure and OCI on how many instances can be a part of the pool. Alright, thanks and congratulations for making it this far. In this lesson, we discussed what you need to know to translate your Azure knowledge and apply it to Oracle Cloud Infrastructure in the compute space. I hope you found this lesson useful. Thanks for watching. Hello and welcome to this demonstration. In this demo, I will show you how you can launch a compute instance. So let's get started. Click on the hamburger icon. Click on Compute. Under Compute, click on Instances. Click on Create Instance. Give it a name. Select a compartment. Select an availability domain under Placement, and if you click on Show Advanced Options, you will get the information on the different types of capacity that you can select. For example, you can go for on-demand capacity or preemptible capacity, capacity reservation, or dedicated host. You can also select the fault domain information. For example, if you would like this instance to be placed in fault domain 1, you can select fault domain 1, or you can also let Oracle choose the best fault domain for you. I will go with this option. Now if you scroll down, you have to provide the information with respect to image and the shape. Shapes are basically virtual hardware configurations. You basically define the number of CPUs, the amount of memory, and the other resources that will be allocated to the instance. And this image is basically the operating system that is going to run on top of this shape. So if I click on Change Image, you can see the different types of image sources: platform images, Oracle images, partner images, and there are other types as well. For example, community images. So I will go with platform images, and here I will go with Oracle Linux. But you can see the different flavors that are available here. Now let me select the shape by clicking on Change Shape. Now here you have the option to specify the instance type. You can either specify a virtual machine or a bare metal machine. This bare metal machine is going to give you a dedicated physical server that provides you strong isolation and highest performance. You also have the option to select a shape series. For example, you can select AMD, Intel, and ARM-based processors. I am selecting VM.standard.e4 flex, so I can customize the number of OCPUs and the amount of memory. For example, I can go with 22 OCPUs and I can select, let's say, 46 GB of RAM. Then there are networking options, where you need to select an existing virtual cloud network. So let me go ahead and select the test VCN and select an existing subnet. So I'll go with public subnet. And you also want to assign a public IP address. If you want to, then you select this particular option. And then the next option is with respect to adding an SSH key, right? So let me do one thing. Let me go ahead and generate an SSH key. And I can do that by using a command. The key already exists, so I am just overwriting it. So you see the key is now generated. So if I just try to go to you can see that this is my public key and this is my private key, right? So, and I can see the contents of my public key. So this is the information that I require. I'll copy it and then I will paste my public keys here. So now we need to specify the information with respect to boot volume. I can specify a custom boot volume size. For example, I can specify 60 GB as the boot volume size, and in case you would like to encrypt the volume with a key that you manage, you can also do that. There are some advanced options with respect to management, availability options, where there is an option of live migration, and then there are Oracle Cloud Agents. So you basically can manage your plugins using this option. For example, you can add this Bastion plugin. Let me go ahead and create this compute instance. As you can see, it is currently provisioning, and in some time you'll see the instance as available. Now, as you can see, the instance is now running. So let me try to connect to this instance. And as you can see, I am now connected to this demo instance. So in this demonstration, we looked at how you can launch an instance and how you can connect to it. I hope you found this demo useful. Thanks for watching. Hello and welcome. In this lesson, we will introduce you to OCI storage services, and we will also talk about how the concepts can be compared to storage offerings of Microsoft Azure. So let's get started. Let's first do a quick side-by-side comparison of the storage services of both Azure and OCI, and then we will have a look at the detailed differences. Both Azure and OCI have a concept of object storage. In Azure, it is known as blob storage. That's a part of storage account. OCI calls it object storage. Both also have an archival storage offering. Azure provides blob storage archive access tier, while OCI provides an archive storage tier. The block storage offering in Azure is known as managed disk, and in OCI, it is known as block storage. Both Azure and OCI also offer a shared file system. Azure calls it Azure Files and OCI calls it file storage. Both these providers also provide a bulk data transfer mechanism. Azure has Data Box and OCI has Data Transfer Appliance. Now let's look at some of the details. An Azure storage account contains all your storage data objects, blobs, file shares, queues, tables, and disks. Azure Managed Disks are block-level storage volumes that are managed by Azure and used with Azure Virtual Machines. You can use Data Box as a data transfer mechanism. In OCI, local NVMe is NVMe SSD-based temporary storage. It is the locally attached NVMe device to the OCI compute instance. OCI also provides object storage, block storage, which consists of both block volume and boot volume, and also provides a managed file system. OCI also offers offline data transfer solutions that lets you migrate data to Oracle Cloud infrastructure. Storage Gateway is a cloud storage gateway that lets you connect your on-premises applications with Oracle Cloud infrastructure. Applications that can write data to an NFS target can also write data to the Oracle Cloud infrastructure object storage. As we discussed in the last slide, you can have a quick look at the OCI storage services: local NVMe, block volume, file storage, and object storage. Here we can see OCI data migration services. We are going to discuss offline data transfer mechanisms like data transfer disk, and data transfer appliance in our upcoming slides. We will continue the discussion on storage in our next lesson. I hope you found this lesson useful. Thanks for watching. Hello and welcome. Let's continue our discussion on object storage. Let's first discuss object storage creation process. While creating a storage account in Azure, you specify basics, advanced, networking, and as you can see in the slide, under each of these, you need to specify advanced configuration details. In OCI, you create a bucket, which is a logical container for storing objects. You also have the option to specify encryption options, whether to use Oracle managed or customer managed keys. You can also enable object versioning and auto tiering. Now let's talk about object storage in some detail. In Azure, when you create a storage account, it provides a unique namespace, and that is why its name has to be globally unique. Inside the storage account, you can create a container, and inside the container, you store the data. There are three types of blobs: block blobs that stores unstructured data, page blobs that is the storage for the virtual machine, and append blobs that is optimized for append operations. You can also provide time-bound access to the resource using shared access signatures. In OCI, namespace serves as the top-level container for all the buckets and objects, and each tenancy is provided one unique namespace name that is global. Within each region in your tenancy, bucket names must be unique. However, you can create buckets with the same name in different regions. After you create a bucket, you store data inside it. In OCI, you have pre-authenticated requests, using which your users can access a bucket or an object without having their own credentials. Let's have a look at some of the object storage features. In Azure, you can configure anonymous read access for your containers and blobs. There are three access tiers: hot, cool, and archive. Hot and cool tier can be set at the storage account level, but archive tier can be set only at the blob level. There are also some other features like lifecycle management rules, object replication, and immutability options. In OCI, you can configure the visibility of the bucket to either private or public. There are three storage tiers: standard, infrequent access, and archive. You also have the option to set the default storage tier to archive while creating a bucket. OCI also features auto tiering, lifecycle policy rules, replication policy, and retention rules. And as we discussed in the last slide, there are three object storage tiers. The first is standard storage tier, and this standard tier is optimized for frequent access. Object storage service always serves the most recent copy of the data when retrieved, and the data retrieval is instantaneous. Standard buckets cannot be downgraded to archive storage. The second tier type is infrequent access. It is ideal for data that you access infrequently, but the data must be available immediately when needed. The storage costs are lower than the standard storage tier, but you are charged a data retrieval fees. The third type is archive tier, and it is optimized for data that is rarely accessed. Minimum retention requirement for archive storage is 90 days, but the objects need to be restored before they can be downloaded. There is also a concept of auto tiering in OCI. If you have not accessed an object for 31 days, it directs object storage to automatically move it to the infrequent access tier, as you can see here. And if the moved objects to the infrequent access tier are subsequently accessed more frequently, then the objects are automatically going to be moved to the standard tier. And the best part about this is there is no retrieval and prorated storage fees. OCI also features an object lifecycle management, using which you can create rules to transition the data to lower cost tiers. For example, you can move the data from standard tier to archive tier after 30 days and automatically delete archived objects after 180 days. By using this feature, you can reduce the storage costs and the amount of time you spend manually managing the data. We are going to continue the discussion on storage in the next lesson. I hope you found the discussion on object storage useful. Thanks for watching. Hello and welcome. Let's continue the discussion on storage. Now it's time to discuss block storage. Azure has managed disks while OCI has block volumes. In Azure, there are 4 disk types: standard, HDD, standard and premium SSD, and ultra disk. OCI has 4 different tiers: basic, balanced, higher performance, and ultra higher performance. We are going to look at the details of these in the next slide. In OCI, there are 2 types of volume attachments. You can either go for iSCSI or para-virtualized, and you can configure the size of the volume between 50 GB and 32,768 GB. Now let's talk about OCI volume tiering. As you can see here, there are 4 tiers: basic, balanced, higher performance, and ultra higher performance. Basic provides 2 IOPS per GB, balanced provides 60 IOPS per GB, higher performance provides 75 IOPS per GB, and the ultra higher performance tier provides 90 to 225 IOPS per GB. There is also a feature known as auto-tune performance, which is a big differentiator. This auto-tune performance changes the volume performance to a lower cost when the volume is detached. When the volume is reattached, the volume performance is automatically adjusted to the previous setting. Now let's look at some of the block storage features. In Azure, you can enable shared disk feature that allows you to attach the disk to 2 or more virtual machines depending on the storage type and the disk size. In OCI, you have 3 access type options to choose from while attaching the block volume to an instance. You can go for read-write. You can also select read-write shareable, and you can also configure read-only shareable. With respect to storage redundancy, Azure has 2 options: locally redundant storage or LRS and zone redundant storage or ZRS. However, ZRS is supported with premium and standard SSD and not available in all the regions. In OCI, you have the option to enable asynchronous cross-region volume replication. Another differentiator is that in Azure, resizing an operating system or a data disk requires the VM to be deallocated, while in OCI, both online and offline resizing is supported. You can expand the volume size without detaching the volume from an instance. As we discussed in the earlier slides, with this read-write shareable option, you can attach a volume to more than one instance at a time, and those instances can read and write the data to the volume. To prevent data corruption from uncontrolled read-write operations with multiple instance volume attachments, you must install and configure a cluster-aware solution for the system before you can use the volume. One such solution is Oracle Cluster File System. Just to reinforce, the block volume service provides you the capability to perform ongoing automatic asynchronous replication of block volumes and boot volumes to other regions. And as you can see in the slide, these are some of the use cases, be it for the purposes of disaster recovery or migration or business expansion. In OCI, there is a concept of volume groups. It provides you with the capability to group together multiple volumes. This simplifies the process to create time-consistent backups of an enterprise application that span multiple storage volumes across multiple instances. We are going to continue the discussion on storage in the next lesson. I hope you found this lesson on block storage useful. Thanks for watching. Hello and welcome. Let's continue our discussion. Now let's look at file storage. In Azure, file shares are deployed inside a storage account There are two types of file shares, standard file share and premium file share. Depending on the type of replication option you select, you get different flavors. Premium file shares can span up to 100 TB and are built by the provisioned share size regardless of the used capacity. In OCI file storage, there are two constructs. The first is file system and then there is mount target. Mount targets are NFS endpoints that are used to access file systems. The file storage service supports the network file system version 3.0. You can connect to a file storage service file system from any bare metal virtual machine or container instance in your virtual cloud network. You can also access a file system from outside the VCN using VCN peering, Fast Connect or IPsec VPN connections. Storage provisioning is fully managed and automatic as you scale from a single byte to exabytes without upfront provisioning. And this is another differentiator. As you can see here, you can use the file storage services for high performance shared storage. The file storage service supports the network file system version 3.0. The service also supports snapshot for data protection of your file systems. Snapshots basically are a consistent point-in-time view of your file systems, and all the data is encrypted at rest. In-transit encryption provides a way to secure your data between the instances and mounted file systems using transport layer security encryption. As you can see in this architecture, it basically depicts how the file storage service can act like a shared storage. Now let's look at some of the file system features. In Azure, there are three tiers: transaction optimized, hot, and cool. There is also a service known as File Sync that allows caching of file shares on Windows servers for local access. SMB file shares are accessible from Linux, Windows, and macOS clients, whereas NFS file shares are accessible from Linux or macOS clients only. In OCI, a mount target is an NFS endpoint that lives in a VCN subnet of your choice and provides network access for file systems. The mount target provides the IP address or the DNS name that is used together with a unique export path to mount the file system. A single mount target can export many file systems, and the file systems can be mounted from either Windows or Linux. Lastly, let's have a look at data migration or data transfer options. Azure has import, export, and a data box family that includes data box disk, data box heavy, and you can see the total capacity information in the slide. You can also use Azure Data Factory service to create a copy pipeline. Oracle offers offline data transfer solutions that let you migrate the data to Oracle Cloud Infrastructure. And as you can see here, there are three options. The first is data transfer disk, then there is data transfer appliance, and then there is storage gateway. Disk-based data transfer requires you to purchase the disk used to transfer the data to Oracle Cloud Infrastructure. The disk is going to be shipped back to you once the data is successfully uploaded. In appliance-based data transfer, Oracle supplies the transfer appliance and software that is required to manage the transfer. And the third option is storage gateway, that is a cloud storage gateway that lets you connect your on-premises applications with Oracle Cloud Infrastructure. Applications that can write data to an NFS target can also write data to the Oracle Cloud Infrastructure object storage. And as you can see in the slide, there are two options. If you have got low bandwidth, you can use the data transfer service, and if you have got high bandwidth, you can go ahead and use the storage gateway. This slide talks about the 2 petabyte scale offline data transport solution, data transfer disk, and data transfer appliance. Next is storage gateway service. The storage gateway is installed as a Linux Docker instance on one or more hosts in your on-premise data center. The storage gateway is going to expose an NFS mount point that can be mounted to any host that supports NFS v4 client. And the storage gateway mount point maps to an object storage bucket. Alright, to wrap up, in this lesson we talked about OCI storage services. We had a look at object storage, block storage, file storage, and the data transfer options. And we also talked about how the concepts can be compared to storage offerings of Microsoft Azure. I hope you found this lesson useful. Thanks for watching. Hello and welcome to this demonstration. In this demo, I will show you how you can work with the object storage offering of Oracle Cloud Infrastructure. So basically, we are going to look at how you can create a bucket and how you can upload an object inside the bucket. So let's get started. Click on the hamburger icon, click on Storage, and under Object Storage and Archive Storage, click on Buckets. Let me first go ahead and create a bucket. Let me give it a name. So I have provided the bucket name as demo bucket. You can also configure the default storage tier to be either of the type standard or archive. There are other features as well that you can enable. For example, you can enable auto tiering that automatically moves the infrequently accessed objects from the standard to infrequent access tier. You can also enable object versioning. You can use the event service to create automation based on the state changes, right? And you also have the option to specify encryption using your customer managed keys. So the keys will be stored inside the OCI vault and you can make use of those keys instead of Oracle managed keys. I'm keeping all the options as default and let me go ahead and create the bucket. Now, as you can see here, the demo bucket is created successfully and the default storage tier is standard and the visibility is private, right? So let me go inside the bucket. And the first thing that I want to do is let me edit the visibility to public. So I have made the bucket public. Of course, this is not a best practice when it comes to production setup, but this is a demonstration. So I just made this bucket public. And now I am going to upload objects inside the bucket. So let me upload a sample object. I will give it a name. I'll select the tier. And you have three options: standard, infrequent access, and archive tier. We have already discussed this in the theory modules. Now let me go ahead and select the file. And click on upload. As you can see, the object is now uploaded. And if I try to view the object details, I have the URL path. Let me copy this link and try to open it in a new tab. And you can see the logo for Oracle Cloud Infrastructure, right? And why am I able to access this? I'm able to access this because the bucket is public. The moment I edit the visibility of the bucket back to private, if I come here and try to refresh the page, you see, I'm not able to access this object, right? So in this demonstration, we created a bucket and we uploaded an object and we tried to access that object. I hope you found this demo useful. Thanks for watching. Hello and welcome to this demonstration. In this demo, we are going to talk about pre-authenticated requests. As you can see, we created a bucket in the last demonstration with the name demo bucket. We also uploaded an object inside that bucket. And if I click on view object details and I copy this URL path and try to open it in a new tab, you see that I'm not able to open this object or access this object. Why? Because my bucket, As you can see here, my bucket is private. Now, how do I provide access to this particular object to any user who is not authenticated? So for that, we can make use of pre-authenticated request. So let me go ahead and create a pre-authenticated request for this particular object. So let me click here and create pre-authenticated request. Now you can define a name. You can also define the request target. In my case, it is object. And you can also define the access type, whether you want to permit object reads or maybe permit object writes, or you want to permit both object reads and writes. You can also specify the expiration time. For example, I want it to expire on 12th, right? So let me go ahead and create pre-authenticated request. Now, as you can see, it has generated an URL for me, and this URL is not going to be shown again. So you have to make a note of it. So let me copy this URL. Let me go to the incognito or in private window, and let's try to open it. As you can see, I have not provided any authentication, but I am able to access the object. This is made possible with the help of pre-authenticated request functionality. I hope you found this demo useful. Thanks for watching. Hello and welcome. In this demonstration, I am going to show you how you can create block volumes in Oracle Cloud Infrastructure. So let's get started. Click on the hamburger icon. Click on Storage. Under Block Storage, click on Block Volumes. Click on Create a block volume. Provide a name. Select a compartment. And as you can see here, you can select any of the availability domains. So this block volume resides within a particular availability domain. Then you can define the volume size and performance. The default volume performance tier is balanced, but you can also go ahead and select custom, and you can provide the volume size between 50 GB and 32 TB. For example, let me provide 2 TB. And then there are these different tiers: lower cost, balanced, higher performance, and ultra higher performance. So let me go with higher performance. I can also configure a backup policy. I can configure cross-region replication. I can also encrypt this volume using customer managed keys. I'm keeping all these values as default, and let me go ahead and create a block volume. And as you can see, the block volume has now been created successfully and is now available. So now you can go ahead, click on attached instances, click on attach to instance. Then you can define the attachment type to either iSCSI or para-virtualized. So let me click on para-virtualized, and you can define the access type, whether you are going to configure it as read-write access or you want to share it with other instances. And you can select the instance. For example, I select demo instance, and then you can select the device path, and then you can click on attach. And as you can see here, the volume is getting attached to this instance, and in some time you will see the state change as attached. And as you can see here, the volume that we created is now attached to this demo instance. So in this demonstration, we saw how we can create a block volume and how we can attach it to a compute instance. I hope you found this demo useful. Thanks for watching. Hello and welcome. In this lesson, we will talk about databases and we will also have a look at how the OCI offerings compare to Azure in this space. So let's get started. Let's first do a quick side-by-side comparison of some of the database offerings of both Azure and Oracle Cloud Infrastructure, and then we will discuss features of some of the services in detail. In the relational space, Azure has Azure SQL Database, Azure SQL Managed Instance, Azure Database for PostgreSQL, Azure Database for MariaDB, and Azure Database for MySQL. In the non-relational space, Azure has Cosmos DB and Azure Cache for Redis, which is an in-memory data store. Azure also has Synapse Analytics Service, which provides data warehousing capabilities with dedicated SQL pools. OCI offers autonomous transaction processing, co-managed database cloud service, and MySQL database service. In the non-relational space, OCI has autonomous JSON database and NoSQL database cloud service. OCI also offers autonomous data warehouse and MySQL HeatWave. Now let's focus on the OCI database services. OCI provides a lot of flexibility to customers who can choose the database service that best meets their customized requirement. At its core, it provides co-managed offering commonly termed as database cloud service, where there is a shared responsibility between customer and Oracle. The co-managed database services can be deployed on different infrastructure and shapes. You may choose virtual machine DB system that is attached to high-performing NVMe storage or a bare metal DB system to support your higher computing needs with dense IO-based storage. You can also provision and manage Exadata systems using a new Exadata resource model and API. You have an option to choose from different editions: Standard, Enterprise, Enterprise Edition High Performance, and Enterprise Edition Extreme Performance. OCI also provides a fully autonomous database service for your different workloads, which includes autonomous transaction processing, autonomous data warehouse, and autonomous JSON. However, if a customer wishes to entirely manage a database instance, just like they would do in their on-premises environment, then they can fully provision the databases in an OCI compute instance. In addition to Oracle, there are some of the non-Oracle managed database services. The first of this is the Oracle MySQL Database Cloud Service, which is a fully managed database service providing a resilient enterprise MySQL database systems in the OCI. Then there is a fully managed Oracle NoSQL Database Cloud Service that is suitable for applications like Internet of Things, instant fraud detection, and it supports JSON, table, and key value data types. Specific type of databases for which OCI does not have a native service, it is possible to deploy them from OCI Marketplace. For example, you can deploy Microsoft SQL Server. Now, talking about the big data space, Oracle provides a fully configured, secured, and highly available and its own distribution of Hadoop technology stack that includes Apache Hadoop for supporting your big data workloads. You can also extend co-managed database services into your data center by using Exadata Cloud at Customer, which applies the combined power of Exadata and Oracle Cloud Infrastructure while enabling you to meet your organization's data residency requirements. Now let's have a look at the relational database offerings of both Azure and Oracle Cloud Infrastructure. Now the first offering is Infrastructure as a Service offering, where there is SQL Virtual Machines. It basically means that you are running SQL Server on Azure VM, and what is the benefit? The benefit is it offers full administrative control over the SQL Server instance, and it provides both SQL Server as well as the operating system access. The second option is the PaaS offering, where you have the concept of fully managed databases. So it can be either SQL database, that is a single database having its own resource, and there are two types of pricing models: database transaction unit and vCore. The second option is Elastic Pool, that implements resource sharing for cost optimization. And the third option is database server. So database server is basically the logical server itself. Then the second option in the PaaS offering is SQL managed instance. It has native virtual network integration and it provides full SQL Server access as well as feature compatibility for migrating SQL servers to Azure. Azure doesn't have a managed Oracle database offering. In OCI, we have seen in the last slide various database offerings. Just to quickly reinforce, there are different deployment options. You can go for virtual machine DB system, bare metal DB system, and Exadata DB system. So these all come under the co-managed systems. And then under the autonomous database offering, you can either go for shared infrastructure model or you can go for dedicated infrastructure model or dedicated infrastructure deployment type. There are two types of DB systems on virtual machines. Single node virtual machine DB system consists of one virtual machine and two node virtual DB system consists of two machines. As you can see, this is a single node Oracle DB on virtual machine and this is Oracle RAC on virtual machines. The maximum number of OCPUs, RAM and storage for your database depends on the shape you choose. Virtual machine DB systems use Oracle Cloud Infrastructure block storage. The bare metal systems that you see here, they basically use NVMe local storage. One thing to note here is that the two-node Oracle RAC DB systems require Oracle Enterprise Edition of the type Extreme Performance. Now, what does an Oracle Autonomous Database do to help our customers? The biggest benefit is the massive decrease in time spent managing databases. Autonomous Database eliminates the complexity of operating and securing Oracle database while giving customers the highest level of performance, scalability, and availability. Operational costs are reduced by automating every aspect of the stack from infrastructure to the database to machine learning based automation. So as you can see here, it provides complete infrastructure automation, complete database automation, and machine learning based automation. In the next lesson, we will continue our discussion on databases. I hope you found this lesson useful. Thanks for watching. Hello and welcome. Let's continue the discussion on databases. Now let me discuss some features that these different services come bundled with, and let's try to understand what makes it so different from other cloud vendors. As you can see, there are different features listed over here and we are going to talk about a few of them. In the newer releases of Oracle, starting with the Oracle Database 19c, it supports converged architecture, wherein you can use the same Oracle database to host multi-model workloads. For example, OLTP, warehouse, XML, JSON, graph, spatial, all can be in the same Oracle Database Cloud Service and can be integrated with the standard SQL interface instead of creating a separate database for a single workload type. Now, Oracle Database in OCI is the same on-premises representation of Oracle Database in terms of release, version, and the features. So there is no compatibility issues between your Oracle database in OCI and on-premises. You can also clone your database with few clicks. You can upgrade your database. You can apply system and database patches with just few clicks. You can enable or disable automated backups, and you can recover your database to certain point in time. So it also provides you that functionality. OCI also automatically takes weekly backups of boot volumes of the VMDB systems so that in event of a VM crash, you can easily restore your virtual machine from this boot volume backup, and there is no extra cost for it. Oracle also provides world's first fully managed Oracle database in the cloud, that is your Oracle Autonomous Database. Under the hood, it is built on Exadata infrastructure and Oracle database with round-the-clock monitoring for detecting and fixing any database faults that may be evident. With Autonomous Database shared infrastructure, you pay only when the database is running, and when it is not running, you just pay for storage. It also comes with 30 plus pre-configured machine learning algorithms that is free to use for your data warehouse analytical needs. Autonomous database in shared infrastructure is entirely managed by Oracle, and it provides an SLA of 99.95% with no exclusions, and that makes it a great database platform to keep your application on. Additionally, all the database services are well integrated with other OCI services such as data catalog, data integration, data safe, and observability and management services. Now, coming into the deployment option, customers have the choice to either deploy their database in Oracle Cloud Infrastructure in the public internet, or they can host the same Oracle Cloud Infrastructure behind their own firewall that is known as Oracle Cloud at Customer. And there is a flexible billing model. It can either be based on a universal credit subscription model or bring your own license as applicable. Now let's have a look at the NoSQL database offerings. In the NoSQL database space, Azure offers Cosmos DB, which is a globally distributed and multi-model database. It is also a fully managed database. When you create your new Cosmos DB account, you can make a choice of API. You can go for Core SQL, Cassandra, Table, Gremlin, or Cosmos DB API for MongoDB. Request units are the throughput and performance currency in Cosmos DB. OCI has autonomous JSON database that also runs on Oracle Exadata hardware. JSON support is integrated into Oracle Exadata to significantly speed up JSON processing. It offers developer-friendly document APIs and native JSON storage. It provides features like always-on encryption and automated patching. Oracle Data Safe is also included with autonomous JSON database. So basically you can perform elastic scaling of compute and storage resources independently without downtime. And it is combined with per second billing, which creates a pay-per-use pricing model. Now MySQL Database Service is a fully managed OCI native service. Oracle automates all the tasks such as backup and recovery, database and operating system patching. You are responsible solely for managing your data, schema designs, and access policies. Now, one thing that is worth mentioning here is that the MySQL Database Service is the only public cloud service built on MySQL Enterprise Edition that helps in providing the highest reliability and security. Lastly, let's talk about MySQL HeatWave. HeatWave is an add-on to MySQL Database Service using which you can run high-performance analytics against your MySQL database without requiring ETL and without requiring any changes in the application. MySQL HeatWave is designed to enable you to run your analytics on the data that you store in the MySQL database so that you don't have to move your data to another database. Alright, to wrap up, in this lesson we talked about databases and we also looked at how the OCI offerings compare to Azure in this space. I hope you found this lesson useful. Thanks for watching. Hello and welcome. In this demonstration, I am going to show you how you can go ahead and create a VMDB system. So let's get started. Click on the hamburger icon. Click on Oracle Database. Click on Bare Metal VM and Exadata. Now once you see this screen, click on Create DB System. You have to provide some basic information like you need to provide the name of a compartment. You need to name your DB system. I will go with the default. You can also select an availability domain. And this is the place where you basically go ahead and select a shape type. So you can either create a VMDB system or a bare metal DB system. The next option is to select a shape. So you see there are different shapes. And depending on the shape that you select, you get different resources like the node count, the core count, and the storage information. So I'll go with this VM standard 2.4 that provides me 4 available core count. And I can also select the total node count. For example, I can make it 2. One thing that you should note here is that if I make the node count as 2, you see that the Oracle Database Software Edition changes to Enterprise Edition Extreme Performance. And if I make it 1, then you have a choice of selecting any edition. For example, I can go with Enterprise Edition. The next option is the storage management software. You can either go for Oracle Grid Infrastructure or you can go for Logical Volume Manager. Then you can configure the storage. I am okay with the default. You can add SSH keys. I already have the SSH key. Let me quickly paste it here. The next option is to select a license type. You can select this license included option, or you may use the bring your own license model. So let me select the license included. Next is to specify the network information. We already created a virtual network and we'll select one of the private subnets in one of the VCNs. So let me go ahead and select the private subnet. And let me give a hostname prefix. Now let me click on next. Now this is the page where you provide information for the database. You need to provide information like the database name, the database image, and you can see there are different versions of Oracle database available here. So I will select 19C. And then I will provide the administrator credentials. The next option is to select the workload type. You can either go for transaction processing or you can select data warehouse. You can also configure database backups. Now let me go ahead and click on Create DB System. Now you can see that it is currently in provisioning state. And as you can see here, this DB system has been created and now you can see that it is available. So this is how you basically go ahead and create a VMDB system in Oracle Cloud Infrastructure. I hope you found this demo useful. Thanks for watching. Hello and welcome. In this lesson, we will discuss security. We will facilitate you in translating your knowledge of Azure Security Services to OCI. Let's first quickly have a side-by-side listing of the security services of both Azure and OCI, and we will get into some of the details in the upcoming slides. In the infrastructure protection category, both Azure and OCI have DDoS protection and web application firewall service. Both also feature virtual network security mechanisms. For example, Azure has network security groups, while OCI has security list as well as network security groups. Azure also has a managed firewall offering with the name Azure Firewall, and OCI has support for third-party network virtual appliances. In the data protection category, Azure has Azure Key Vault service, while OCI has OCI Vault as well as a certificate service. OCI also has a service called Data Safe that is not mentioned here, but we are going to talk about that in the subsequent slides. In detection and remediation, both feature a security posture management service. Azure has Microsoft Defender for Cloud and OCI has OCI Cloud Guard. Azure also has services like Azure Advisor and Azure Policy, whereas OCI has services like security zones and security advisor. And there is also a vulnerability scanning service. In the identity and access management space, Azure has Azure Active Directory, which includes several security capabilities, and OCI has Identity and Access Management Service. Both the providers also provide workload protection services. For example, Azure has Azure Bastion as well as dedicated hosts. OCI also features these services, and additionally, it also has an operating system management service. Lastly, in the auditing space, Azure has activity logs. That's again a part of Azure Monitor, and OCI has audit service. In this slide, you see that OCI provides a layered security mechanism. On the right, you can see the services that are mapped to these layers, and on the left, you can see the use cases of each of these services. And you can see there are different layers, right? So there is infrastructure protection, then there is identity and access management, there is operating system and workload protection, there is this data protection services, and then lastly, there is detection and remediation. The first layer is infrastructure protection, and you can see that OCI has services like DDoS protection, web application firewall. There is also security list, network security group, as well as option to use network virtual appliances. The second layer is identity and access management, where there are services like OCI Identity and Access Management, things like multi-factor authentication, the OCI audit service, as well as federation. In the operating system and workload protection layer, OCI has shielded instances that harden the firmware security on bare metal hosts as well as the virtual machines, basically to defend against malicious bootlevel software. It also has dedicated host, the Bastion service, and operating system management service that basically allows you to manage and monitor updates and patches for the operating system environments on your Oracle Cloud instances. In the data protection layer, OCI has a vault service that provides a centralized key storage. There is also a service known as Data Safe, which provides features like security assessment, user assessment, data discovery, data masking, and activity auditing. OCI also provides an OCI certificate service. Lastly, in the detection and remediation space, OCI provides services like CloudGuard, which is a security posture management service, and security zones that ensures you comply with Oracle security principles and best practices. OCI also provides services like Security Advisor and vulnerability scanning, which routinely checks hosts for potential vulnerabilities. As you can see here, all the Oracle Cloud security capabilities have been designed with one goal in mind, and that is to allow you to run your mission-critical workloads in the cloud with complete control and confidence. In the upcoming slides, we will look at some of these services, and we'll also talk about how you can relate it with Azure Security Services. Let's first look at infrastructure protection. In Azure, DDoS protection comes in two flavors: Basic and Standard. Basic is free and provided for all the accounts. Standard DDoS is a chargeable service that can be enabled by associating a protection plan. In OCI, DDoS protection is included with all the accounts and no configuration or monitoring is required. This DDoS protection service protects against layer 3 and layer 4 attacks like SYN flood, UDP flood, etc. Both Azure and OCI also feature a web application firewall service that lets you protect your web application from common web exploits like cross-site scripting and SQL injection attacks. OCI WAF can be attached to a load balancer or a web application domain name. It can also be used for edge enforcement. Now, when it comes to virtual network security, Azure has network security groups that can be associated with subnet or VNIC, and it basically helps in filtering inbound and outbound traffic. Azure also offers a managed firewall offering known as Azure Firewall, using which you can configure network and application rule collections as well as define NAT rules. In OCI, there are two constructs when it comes to VCN security. We have mentioned security list that can be attached to a subnet. It can be stateful or stateless. There is also a network security group that you can attach to a VNIC. Both security list and network security group consist of a set of ingress and egress rules that can be either stateful or stateless. You can also use third-party network virtual appliances or NVAs like Checkpoint, Fortinet, Palo Alto, Cisco Next Generation firewalls using OCI Marketplace. We are going to continue the discussion on security in the next lesson. I hope you found this lesson useful. Thanks for watching. Hello and welcome. Let's continue our discussion on security. Let's talk about data protection. In Azure, you can manage keys, secrets, and certificates using Azure Key Vault service. There is support for both software as well as hardware security module backed keys. OCI also has a service with the name OCI Vault that you can use to manage keys and secrets. The Vault service recognizes three types of encryption keys. The first is master encryption keys, the second is wrapping keys, and the third is data encryption keys. Master encryption keys can have either HSM or software protection mode. There are many OCI services like object storage, file storage, and block volume that integrate with the Vault service to support the use of customer managed keys to encrypt the data. And then there is another service with the name of OCI certificates. It provides capability to provision and manage the lifecycle of a public and private certificate. If you have a third-party certificate authority that you already use, you can also go ahead and import certificates issued by that certificate authority for use in your tenancy. Now, OCI Vault, as we discussed, is a managed service that lets you centrally manage encryption keys and secret credentials. Vault removes the need to store the encryption keys and secrets in a configuration file or in code. There are two protection modes available for keys. The first is software, and then you also have hardware security modules. Vault supports different algorithms like AES, RSA, and ECDSA. Keys are integrated in OCI services and can be used to encrypt block volumes, object, and file storage. The Vault service also supports rotating master keys to meet your crypto period requirements. Now, this slide talks about how envelope encryption actually works. When you upload a plain text data to the object storage service, the service calls OCI Vault. Now, the Vault service returns both data key as well as encrypted data key. And that is the reason why you see these two boxes. Now, the object storage is going to use the plain text version of the data key and it performs the encryption. Now, what is stored here? You see there is an encrypted data and encrypted data key that is stored in the bucket. Now, at the time of making a request to decrypt this data, the object storage now makes a request to the Vault and it sends the encrypted data key as part of the request. Now, Vault is going to look at the encrypted data key, and as it has the master key, it is basically going to stripe out the other portion and it is going to send the data key back. Remember, this is the data key that was used to perform the encryption, and using this data key, we are going to perform the decryption and generate the plain text data. So this entire process that I explained to you is what is known as envelope encryption. Now let's talk about detection and remediation. Both Azure and Oracle Cloud Infrastructure have a security posture management service. In Azure, it is known as Microsoft Defender for Cloud. Previously, this service was also known as Azure Security Center. This service provides recommendations to harden the resources deployed and also provides a secure score. The secure score is a reflection of the security posture of your Azure deployments. In OCI, there is a service known as CloudGuard that can be used to examine the resources for security weaknesses related to configuration, as well as to examine the users for risky activities. And upon detection, we can configure the CloudGuard to automatically take corrective actions. Azure has a service named Azure Advisor that helps to optimize deployments for security, reliability, cost, performance, and operational excellence. OCI also has a similar service known as Security Advisor that we will discuss in the next slide. But before that, I would like to talk about an OCI service known as Security Zones. Well, Security Zones is a service that ensures your resources comply with Oracle security principles. And security zones are always associated with a compartment. When you create or update resources in a compartment that is associated with this security zone, OCI validates the operations against security zone policies. And if there is any violation in the security zone policy, then the operation is going to be denied. There is a concept of security zone recipes, which is nothing but a collection of security zone policies. Now, your OCI tenancy has a predefined recipe that is known as maximum security recipe. And this maximum security recipe is going to include all the security zone policies. This recipe is managed by Oracle and you cannot modify it. Azure has a service known as Azure Policy that helps to enforce organizational standards. This can somewhat be mapped to the OCI service that we discussed in the previous slide, known as security zones. Using Azure policies, you can assess compliance at scale. There is another Azure service that's a part of Microsoft Defender for Cloud Service, and that is known as Vulnerability Assessment Solution. In OCI, Security Advisor workflows help you create resources that abide by the enhanced security requirements of such environments. And then there is a vulnerability scanning service which helps in improving the security posture by routinely checking the hosts for potential vulnerabilities. This service is also going to generate a report with metrics and details about the vulnerabilities and assigns each risk level. We are going to continue the discussion on security services in the next lesson. I hope you found this lesson useful. Thanks for watching. Hello and welcome. Let's continue our discussion on the security module. As you can see here, a security zone is associated with a compartment. You see, there are two compartments, compartment A and compartment B, and we have associated this particular security zone with compartment B. Now for the compartment that is associated with the security zone, OCI validates resource operations against a set of policies that are also known as security zone recipes. And if any security zone policy is violated, then the operation is going to be denied. Now let's talk about identity and access management. Azure has Azure Active Directory, which provides security features like multi-factor authentication and conditional access policies. There is also an identity protection service. You can also grant approval-based just-in-time access, but that requires a premium P2 license and is charged separately. OCI has Identity and Access Management Service that provides various constructs like policies and dynamic groups. It also provides multi-factor authentication, and there are no charges for using this feature. You can also reference network sources in your policies to restrict access based on a certain source location. Now let's have a look at the next layer, which is operating system and workload protection. Both Azure and OCI have a managed Bastion service that provides restricted access to resources that don't have public endpoint. The main differentiator is that in OCI, there is no cost for using this service. Both the providers also feature a dedicated host service that lets you run virtual machines on a dedicated server. OCI also provides an OS management service to manage and monitor updates and patches. We have talked about OCI Bastion service, and as you can see in this architecture, there are instances deployed in private subnet inside a virtual cloud network. Through the configuration of Bastion, you basically let authorized users to connect to target resources on private endpoints by way of SSH sessions. Bastions reside in a public subnet, and you can also specify what IP addresses can connect to a session that is hosted by this Bastion. And it basically removes the need to create and manage your own Bastions. Now let's have a look at auditing. Both Azure and OCI provide a service to record API calls. In Azure, it is a part of Azure Monitor service and is known as activity logs. And in OCI, it is known as audit service. In Azure, activity log provides insights into subscription level events. You can export activity logs to multiple destinations like event hubs by creating a diagnostic setting, and the logs are retained for 90 days. In OCI, log events recorded by the audit service include API calls made by the console, command line interface, SDKs, your own custom clients, or any other Oracle Cloud Infrastructure services. The audit logs are retained for 365 days, and you can also export these logs. Exported logs remain available indefinitely. Alright, to wrap up, in this lesson we discussed security, and we also talked about how we can translate our knowledge of Azure Security Services to OCI. Hope you found this lesson useful. Thanks for watching. Hello and welcome. In this demonstration, I am going to show you how you can create a security zone. So let's get started. Click on Identity and Security and click on Security Zones. As you can see here, there are a number of security zones that are already created in my tenancy. And on the left, you can also see recipes. So this recipe is basically a collection of policies, and you can see there is one Oracle managed recipe that is provided to all the customers. And the name of this recipe is Maximum Security Recipe. So if I click here, then you can see that there are different policies that are associated with this recipe. I want you to focus on one of the policies: deny buckets without vault key. That means you cannot create a bucket in your security zone if you don't have a customer managed key. So by default, Oracle manages the key, and if that is the case, you will not be able to provision buckets in your security zone. So let's do one thing. Let's quickly go ahead and create a security zone. So let me go ahead and create a security zone. I will name it Samvit S zone. I'll provide the same as description, and I will create it in my compartment Samvit. Now let me go ahead and click on Create Security Zone. Now you see that this security zone is now created, and this security zone is associated with this maximum security recipe policy. Now let's go ahead and see this in action. Let me take you to the storage. object storage and archive storage. Now let me select a compartment that we created. Now if I try to create a bucket using the Oracle managed keys, then let's see what's going to happen. So I'm keeping all the options as default. Please pay attention that I am using Oracle managed keys. Now if I try to create this bucket, it says security zone violation. And what is the message that it provides? It basically specifies that you cannot encrypt the bucket with Oracle managed keys, and you have to use a customer managed encryption key to create a bucket. Why this is so? Because this is a security zone, and whatever resources are deployed inside a security zone, they are governed by the policies that is defined in the recipe. Now let me do one thing. Let me select this compartment, Submit demo compartment, and let me try to create a bucket. Now this time I will use the default configuration and I will click on create bucket. And you see this creation is successful. Why? Because this is not a security zone. And this was a quick demo of security zones, and we have seen that how you can make the resources comply with security best practices. I hope you found this demo useful. Thanks for watching. In this lesson, we will talk about application development services, and we will also see how the OCI concept can be compared to offerings of Microsoft Azure. So let's get started. Let's first do a quick side-by-side comparison of the offerings of both Azure and OCI. Both the providers have a container registry offering. Azure calls it Azure Container Registry and OCI calls it Container Registry or Oracle Cloud Infrastructure Registry (OCIR). Both Azure and OCI have a managed Kubernetes service. In Azure, it is known as Azure Kubernetes Service, and in OCI, it is known as Container Engine for Kubernetes or OKE. In the functions as a service space, Azure has Azure Functions and OCI has Oracle Functions. Both the providers also have a serverless API gateway. Azure calls it Azure API Management and OCI calls it API Gateway. In the DevOps space, Azure has Azure DevOps and OCI has OCI DevOps Service, which provides a platform for continuous integration and continuous delivery for developers to simplify and automate the software development lifecycle. Lastly, both the providers also have a deployment service that helps you automate the process of provisioning. Microsoft Azure has Azure Resource Manager, which is also known as ARM, and OCI has OCI Resource Manager. Resource Manager basically uses Terraform to help you provision, configure, and manage Oracle Cloud Infrastructure resources. Now let's talk about Container Registry. In Azure, Azure Container Registry is used to store and manage your private Docker container images and related artifacts. Azure Container Registry supports Docker-compatible container images and Open Container Initiative image format specification. It provides integrated security and supports integration with several Azure services. In OCI, Oracle Cloud Infrastructure Registry, also known as Container Registry, is an Oracle managed registry that enables you to store, share, and manage container images. It is a regional service. It is integrated with OCI IAM and other services like functions, OKE, vulnerability scanning, and Vault. You can set up image retention policies to automatically delete images that meet particular selection criteria. For example, images that have not been pulled for a certain number of days can be automatically deleted. So OCIR is an Oracle managed registry that simplifies the development production workflow. Container registry makes it easy to store, share, and manage Docker images, and the highly available and scalable architecture of OCI ensures that containerized applications can be readily deployed. You can use container registry as a private Docker registry for internal use. However, it can also be used as a public registry, enabling any user with internet access and permissions and knowledge of the appropriate URL to pull images from your public repository. Since OCIR is also an Open Container Initiative compliant registry, you can store any container image that conforms to Open Container Initiative specifications. And Container Registry is integrated with Oracle Identity and Access Management Service, which provides easy authentication with native OCI identity. Additionally, it also supports private access from other OCI resources in a virtual cloud network within the same region through a configured service gateway. OCIR essentially serves as the central registry for all container images throughout an OCI tenancy region. Built using OCI object storage, Container Registry provides data durability and high service availability with automatic replication across OCI fault domains. Built-in integration with OKE is a primary use case for the registry, where you can create private co-located container repositories for low latency deployments. And since Oracle Function leverage Docker containers and a serverless architecture, you can also take advantage of the same low latency deployment capability, since private repositories can be automatically created or updated using the FN project command line interface. And for all of your containerized applications that you may instead choose to deploy to either bare metal or virtual machine compute resources, it becomes much easier to leverage either dedicated public or private repositories depending on the location of your DevOps, continuous integration, and continuous deployment pipeline tools. We are going to continue the discussion on application development services in the next lesson. I hope you found this lesson useful. Thanks for watching. Hello and welcome. Let's continue our discussion on application development services. Let's talk about managed Kubernetes offering. Azure has Azure Kubernetes Service, where master nodes are fully managed by Azure. Azure Kubernetes Service manages different aspects of a Kubernetes cluster like cluster scaling, version upgrades, and patching. OCI has Oracle Container Engine for Kubernetes. When you'd like to build a cloud-native application, you specify the compute resources that your applications are going to require, and the Container Engine for Kubernetes is going to provision them. Any Kubernetes cluster is made up of control plane components, which manages the cluster, and the worker nodes, which provides compute resources to run the workload. With OKE, the control plane is deployed in a highly available manner and runs on compute instances, also known as control plane nodes, in a tenancy that is managed by Oracle. Worker nodes, on the other hand, are created in the customer tenancy and is managed by the customer. Both virtual machines as well as bare metal hosts are supported as worker nodes. Now let's have a look at the components of a cluster. As we discussed in the previous slide, you can see the control plane and the worker nodes. The cluster control plane runs the number of processes, Kube API server to support Kubernetes API operations requested from the Kubernetes command line tool, as well as from direct REST calls. Then you see the controller manager. It's also known as Kube controller manager, and it manages different Kubernetes components. For example, replication controller, endpoints controller, namespace controller, and service accounts controller. Then there is Kube scheduler to control where in the cluster to run the jobs. Then there is CCM or Cloud Controller Manager. It basically manages calls to OCI. And then we have etcd to basically store the cluster's configuration data. Workloads are run on the worker nodes, a set of worker nodes within a cluster that all have the same configuration is grouped into a node pool. Workloads run as group of containers called pods, and pods are scheduled on infrastructure, that is the node. As you can see here, the control plane node is managed by Oracle and the worker node is customer managed. Now let's look at Functions as a Service offering. Azure has a serverless offering known as Azure Functions. They are created in a function app. You can publish as a code or a Docker container, and there are different runtime stacks supported. OCI has OCI functions. Let me discuss some concepts of OCI functions. The first is function application. It is basically a collection of functions. It is attached to the customer's virtual cloud network, which is VCN and subnet. You can also think of application as a unit for workload isolation. Now, what is a function? A function is a container image that is stored in a container. The metadata is going to contain the image location, the function memory, function timeout, and any configuration parameters or environment variables that is required for the function's execution. FNCLI is a command line tool that is used to manage functions. At a very high level, your uploaded code and configuration is packed as a container image and it is stored in the OCI registry. Then you set up trigger actions. You can invoke using CLI or API, or OCI events can also trigger it, and then Oracle Functions executes the code in response to the trigger or invocation, which can then invoke other OCI services. The thing which makes it really interesting is that it is truly a consumption-based pricing model. You only pay for code execution time. Now let's talk about serverless API gateway offering. Azure has Azure API Management Service, using which you can bring multiple APIs under a single administrative umbrella. OCI has OCI API Gateway. It is a managed service. It's also a regional service. It appears as a network device on the customer VCN. There are features like authorization and rate limiting. What rate limiting does is that it limits the number of API calls you could make to the backend servers. So there are no scenarios where you overwhelm the server. You can also perform monitoring, logging, and it integrates with other services, including Oracle Integration Cloud. In the API Gateway service, a front end is the means by which the requests are going to flow into an API gateway. An API gateway can either have a public front end or a private front end. A public front end exposes the APIs deployed on the API gateway via a public IP address, whereas a private front end exposes the APIs deployed on an API gateway to a VCN via a private endpoint. A backend is the means by which a gateway routes the request to the backend services that is basically going to implement the API. You can grant an API gateway access to other cloud infrastructure services as backend. For example, you can grant an API gateway access to Oracle Functions, meaning you can create and deploy an API that is backed by a serverless function. Alright, to wrap up, in this lesson we talked about some of the application development services, and we have also seen how the OCI concepts can be compared to the offerings of Microsoft Azure. I hope you found this lesson useful. Thanks for watching. Hello and welcome. In this lesson, we will talk about monitoring and observability, and we will also have a look at how the OCI offerings compare to Azure in this space. So let's get started. Both Azure and Oracle Cloud Infrastructure have a monitoring service offering. Azure calls it Azure Monitor and OCI calls it OCI Monitoring. In the logging space, Azure has Azure Monitor Logs and Log Analytics Workspace. OCI has OCI Logging Service and Logging Analytics Service. Both Azure and OCI also have a service for application monitoring. Azure calls it Application Insights and OCI calls it Application Performance Monitoring. Both these providers also have an alerting mechanism. Azure has Azure Monitor Alerts and OCI has Alarm. Now let's have a look at how OCI monitoring service enables you to actively and passively monitor OCI resources using metrics and alarms feature. As you can see in this architecture, there are two constructs. The first is metric and the second is alarm. Now metrics can be used to monitor resources and alarms can be used to notify you when these metrics meet alarm specified triggers. And on the left, you can see that there are services, there are resources that emit metrics continuously. For example, services can be instances, they can be autonomous databases. Now using this metrics, we can perform active monitoring. Now alarms use this metric for passive monitoring. The alarm also has a trigger action and a notification method. When these metrics breach an alarm threshold, for example, CPU utilization is greater than 80%, then an alarm gets triggered and then the alarm sends an alarm message to the configured topic in OCI notification service, which then sends the message to all the topics subscriptions. Lastly, when you query a metric, the monitoring service returns aggregated data according to the parameters you specify, and it is accessible using the console, the CLI, and the API. Now let's look at monitoring. In Azure, you can monitor and visualize metrics. You can query and perform the analysis of the log data, as well as set up alerting mechanism using the Azure Monitor service. There is also an Insights feature using which you can correlate infrastructure issues. You can also perform visualizations using dashboards and workbooks. And there is another service with the name of Network Watcher that helps you in troubleshooting potential network issues. Let's talk about OCI. As we have discussed in the previous slide, OCI monitoring is the native service for monitoring resources. We can use the metric data to set alarms and automate notifications. We have already discussed that architecture. Using Metrics Explorer in OCI console, you can visualize metric charts using default service queries. You also have the option to edit the queries as needed using MQL, and MQL here stands for Monitoring Query Language. You also have the option to publish your own custom metrics to the monitoring service. Many customers ask us how you export the metrics out of the OCI monitoring for analysis in your own system. To facilitate this, OCI has published a serverless function-based solution to enable metrics to be exported to an object storage bucket. A metric is a measurement related to health, capacity, or performance of a given resource. For example, you can monitor the CPU utilization and disk reads of your compute instances. You can then use this data to determine when to launch more instances to handle increased load, or maybe to troubleshoot issues with respect to your instance, or maybe to better understand system behavior. Now let's see how a metric query is composed. So metric contains three constructs. The first is namespace, then you have dimension, then there is metadata. Now what is this namespace? It is basically an indicator of the resource or the service or the application that is going to emit the metric. As you can see here, there is CPU utilization, right? This CPU utilization has the metric namespace OCI underscore compute agent. For CPU utilization, this is the source and this is what is your namespace. The second construct is dimension. Dimension is basically a qualifier to filter or group the metric data. For example, you might apply a filter like all the compute instances that are running in an availability domain. So that is your dimension. And then the third aspect is your metadata. Metadata basically provides additional information for a metric. And the example for metadata can be the unit. We are going to continue the discussion of monitoring and observability in the next lesson. I hope you found this lesson useful. Thanks for watching. Hello and welcome. Let's continue our discussion on monitoring and observability. Let's talk about logging. In Azure, Log Analytics Workspace is the logical storage unit where log data is collected and stored. You must create at least one workspace to use Azure Monitor Logs. After you create a Log Analytics workspace, you basically go ahead and configure sources to send the data and configuration options. And the configuration options can vary depending on the data source. Now, once you collect the data, you can write the log queries using custom query language or KQL in Log Analytics to interactively analyze the results. In OCI, using the logging service, you can enable, manage, and search logs. There are basically three kinds of logs: audit logs, service logs, and custom logs. So let's have a look at each one of them. What are these audit logs? These audit logs are related to events that are emitted by the OCI audit service. The next is service logs. Service logs are emitted by OCI native services like API Gateway, Object Storage. Now each of these services has a predefined logging category that you can enable or disable on your respective resources. Then there is a custom log that basically contains diagnostic information from custom applications, or it can be other cloud service providers or even an on-premise environment. And then there is another service, logging analytics, using which you can get operational insight from your logs. The service relies on machine learning to rapidly identify patterns and anomalies in your log data. You can also use the cluster feature to reduce millions of log entries down to a small set of interesting log signatures, making it easy for you to review. As we discussed in the last slide, OCI logging service provides centralized log management, and as it is built on open standards, developers can use hundreds of open source community plugins to ingest, parse, and enrich their logs. We have also talked about the three types of logs: audit log, custom log, and service logs. Logging analytics makes it easy for users to unlock the value of the log data for any source across on-premises, Oracle Cloud, or maybe third-party clouds such as AWS and Azure quickly and without involving data scientists. It also provides a topology-aware exploration that helps in quickly exploring relevant logs pertaining to the impacted environments and the time of the incident under investigation. Now let's look at application monitoring. In Azure, Application Insights provides monitoring for live web application. It detects performance anomalies and helps diagnose issues. It also helps the development teams understand how the application is performing. In OCI, Application Performance Monitoring provides a comprehensive set of features to monitor applications and diagnose performance issues. OCI Application Performance Monitoring enables monitoring of multiple components and application logic that is spread across clients, third-party services, and back-end computing tiers that are deployed on either the cloud or the on-premises environment. You can think of this application performance monitoring as a robust implementation of a distributed tracing system as a service. There are several features. One of them is synthetic monitoring. Think of it like a proactive monitoring strategy that helps developers prevent issues before users are impacted. This service also provides real user monitoring. That means you can track the actual experience of each end user. It also facilitates app server metric collection through server monitoring. Time to talk about alerting mechanism. Azure has Azure Monitor Alerts. Basically, you define the scope, you define signals, what is going to be the criteria, and the severity as well as the action. You can set the state of an alert to specify where it is in the resolution process. And there are three different states: new, acknowledged, and closed. There's also a concept of action group, that is a collection of notification preferences and actions. OCI also has an alerting mechanism, and it is known as alarm. While creating an alarm, you define the severity, you specify a namespace, that is basically the source service which is emitting the metric. You also specify the metric name, the interval, and the statistic. You think of the statistics like an aggregation function. You also specify metric dimensions to filter the metric data, and you specify the trigger rule, that is basically the condition for putting the alarm in firing state. You also define the notifications using the topic functionality. There are three different states for alarms: firing state when it is triggered, reset when you reset it back, and the third one is suspended if it is in a suspended state. As you can see in this particular illustration, you start with a resource which is emitting metric data into the monitoring service, and then if a particular threshold is breached, the alarm is triggered. And when an alarm is triggered, it sends an alarm message to a configured topic. Topic, you can think of it like a published pub/sub method in notification service, which is then going to send the message on all the topic subscriptions. And you can see a bunch of these subscriptions listed here. It can be an email, it can be a serverless offering known as functions, or Slack, or SMS. So that is how the alarms work. Well, to wrap up, in this lesson we talked about the monitoring services, and we also had a look at how the OCI offerings compare to Azure in this space. I hope you found this lesson useful. Thanks for watching. Hello and welcome. In this demonstration, I am going to show you some of the services in the monitoring space. So let's get started. First, click on the hamburger icon. Go to Observability and Management and click on Monitoring. The first thing that you see here is service metrics. So let me go ahead and select the compartment and select a metric namespace. Think of this metric namespace as the source service that is emitting the metric. And as you can see here, there are different metric namespaces. For example, OCI underscore compute agent, OCI underscore block store, OCI underscore object storage, right? So let me go ahead and select OCI underscore compute agent. The moment I select metric namespace, I am able to see different charts with respect to CPU utilization, memory utilization, disk write IO, disk read IO, disk read and disk write bytes. So you can see all this information, network transmit bytes. What you can also do is you can add a dimension. So you can think of this dimension as a mechanism to filter the metric data. So let me go ahead and add a dimension. I can specify the dimension value as, let's say, availability domain, and I can specify the dimension value. For example, all the instances running in the availability domain 1. And as per the dimension, you can see the charts will now get updated. Now the second thing that I wanted to show you is Metrics Explorer. Now if you see here, you can specify the start time and the end time. So let me just select the start time and the end time. And after that, you can specify the metric namespace. Let me go ahead and select OCI underscore compute agent. And let me select a metric name. For example, I can go with memory utilization. And I can specify the interval, 1 minute, 5 minute, 1 hour, or 1 day. I can also define the statistic. I can also provide a value for the dimension, availability domain, AD1, and I can click on update chart. And as you can see here, you will be able to see the updated chart. And in case you would like to write your own queries, you can just select this advanced mode and just scroll down. And this is where you can write your own queries in the query code editor using MQL, monitoring query language. Now the other thing that I wanted to show you in this demonstration is with respect to alarms. So let me click on alarm definitions and let me show you how do you create an alarm. So click on create alarm. Give your alarm a name. So the alarm name is high CPU utilization, and then you have to provide the metric description. I'll select the metric name. I'll specify the interval and the statistic. You can also provide the dimension name. And what is going to be the trigger rule for putting the alarm in the firing state? If the CPU utilization is greater than, let's say, 80%, then I want the alarm to be in the firing state. And when the alarm is in the firing state, what action do you want to be performed? So here I can make use of the notification service to create a topic. So let me go ahead and create a topic. So I'll give the topic a name. The description is optional, and you can define the subscription protocol, and you have choice of either sending an email, triggering a function, or Slack or SMS, right? So there are different options. And then let me select email and specify the email address. So let me go ahead and click on create topic and subscription. So as you can see, we have the option to enable this alarm. So let me go ahead and click on save alarm. So this is how you work with the metrics and alarms. I hope you found this demo useful. Thanks for watching.